Do you ask yourself, what would Jesus do every time you have to solve a math problem? Perfect. We can help you avoid calling the Lord's name in vain by watching this here video by Fort Bend Tutoring and Mr. Witt.
Hello ladies and gentlemen, this is Mr. Witt with Fort Bend Tutoring, and today's tutorial is going to be about finding the mean absolute deviation. That's right, we're going to find out how to get mad. The mean absolute deviation. So let's check it out. So if you want to know how to get mad, then what you want to do first is you want to, one, find the average, the mean of the data set. That's right. And what is the average? How do we find the mean? If you recall, all you have to do is find the sum of all the values in your data set, and then you're going to divide by the amount of values in that data set. And of course, I'll be showing you that process in each one of our examples in this video. That's right. The next thing to do is to find the positive difference between the mean and each value in the data set. So you'll be finding the absolute value of the difference of each one of the values and the mean of the data set. Now, let's look at the next two steps. In our next step, you'll then find the mean of the positive differences. So all of those changes that we found between each of the values in the data set and the mean, you want to make sure that it's going to be a positive result, aka the absolute value of that difference. And then finally, if needed, you'll be rounding your result to the requested place value. So if your teacher textbook or your assignment ask you to round to the nearest tenths place, for instance, or to the nearest unit, or to the hundredths place, depending on the directions of your particular assignment and problem, you may need to round your result. All right, so there you go. Let's look at some examples now. In example 1, we have the data set that includes 2, 5, 9, 3, 5, 2, and 2. And according to our steps for finding the MAD, what we want to do first is find the average of these numbers right here. So how many numbers are in this data set? Let's figure it out. We'll have 1, 2, 3, 4, 5, 6, 7 numbers that you'll need to find the average of. So what I'm going to do is I'm just going to write these vertically because that's how I do it. So I'm going to end up with 2, 5, 9, 3, 5, 2, and 2. And I'm going to add all of this together. All right, let me get that in view. Let me get that in view for you. So let's make sure we have the numbers correct. It's 2, 5, 9, 3, 5, 2, and 2. Everything's there. We have 1, 2, 3, 4, 5, 6, 7 values. Notice how I'm making sure that all my values are present before I find the average. So let's add this up. I have 2 plus 5, which is 7. 7 plus 9 is 16. 16 plus 3 gives me 19. 19 plus 5 is 24. 24 plus 2 is 26. And then 26 plus 2 is 28. There you go. So you have 28. That's the sum of your values in the data set. To find the average of those numbers, you'll need to divide that by the total amount of values that you have. And we have 7 numbers, right? So that's why I'll be dividing 28 by 7. 7 goes into 28 how many times? Exactly, 4 times. You guys are sharp. You are really, really sharp. So yeah, so 4. That's right, 4 is the mean. Okay, so now that we have our mean of 4, what you want to do next is you want to find out the difference between the mean 4 and each one of the values in our data set. All right, so let's go ahead and move to the next page so we can check that out. All right, so let's find the difference of each one of these values. Remember that the mean or the average of the data set is 4. So we'll be taking the difference of 4 in each one of the values. The first value that we had was the number 2. So the difference between 4 and 2 is 2. All right, so that's the first one. And then we'll take the next value, which is 5, and find the difference of 5 in the mean. So since 5 is the biggest number, we'll put that one on top this go around. So 5 minus 4 gives us a value of 1, a difference of 1. Then our next digit was 9 in the data set. So the difference between 9 and 4 is going to give us 5. Then moving along, we're going to find the difference of 4 and 3. So we have 4 minus 3, and this gives us 1 here. Then from there, we're going to look at the difference between 5 and 4. So that's going to be 5 minus 4 again. All right, just making sure we're being thorough. And then after that, you have the difference of 4 and 2. So finding the difference of 4 and 2 is up next, and we have 2 as a result. And then finally, our last value is 2 again. Yeah, it's 2. So I'm going to find the difference between 4 and 2 now. All right. So now I have all of our positive differences. Those differences were 2, 1, 5, 1, 1, 2, and 2. When we found that positive change, each one of these is the deviation. It's the change between the average mean value and each of the numbers in the data set. So next we need to find the average of these values. So adding these 7 digits together, we'll end up with the following list here. We'll have 2, 1, 5, 1, 1, 2, and 2. All right. Adding these values together, you'll end up with 14. All right. And how do we get that 14? We added it together. We said 2 plus 1 was 3. 3 plus 5 is 8. 8 plus 1 gives us 9. 9 plus 1 is 10. 10 plus 2 is 12. And 12 plus 2 is 14. All right. Now, because we're finding the average of this value, we need to divide 14 by what? Exactly. We need to divide by 7. Man, you're on top of things today. So you're going to have the 7 going into 14. We know that 14 can be divided by 7 twice. And this 2, ladies and gentlemen, is the answer. That's right. That's the MAD that we were looking for. I'm going to put a red box around this. I like red boxes around my answers. So for problem number 1, our mean absolute deviation is 2. That's it. And now we'll be moving on to problem number 2. All right. We now have problem number 2. And in this data set, we have 7, 3, 7, 9, and 9. Notice that we don't necessarily have to arrange this in ascending order. So it's not like we're trying to find the median here, where it is a must that you arrange your digits from least to greatest. You don't have to do that when you're finding the mean absolute deviation. All right. All we need to do, however, is find the average, the mean. So let's find that out. And we find it once again by finding the sum of these digits and then dividing by the amount of values that we have in the data set. And in this case, we have 1, 2, 3, 4, 5 digits. So let's get to finding the average. So adding these numbers together, I'll list them as 7, 3, 7, 9, and 9. And we want to find the average of these 5 digits. All right. So adding 7 plus 3, we get 10. 10 plus 7 is 17. 17 plus 9 is going to give us 26. And then 26 plus 9 is 35. So we get 35 for our sum. So now I end up dividing 35 by 5. So I have 5 going into 35. And as you well know, 5 goes into 35 7 times. That's right, it's this 7 that's the mean of our data set for problem number 2. So we had 7, 3, 7, 9, and 9, and the average of those numbers, the mean value of those numbers is 7. We want to find out the difference, the change, the deviation in each of the values in our data set when compared to our average 7. All right, so let's check that out. So the first value, remember, was 7. Okay, so 7 minus 7 is 0. Yeah, it's 0. Then we'll find the difference between 7 and 3. That's going to be 4. Then we want to find out the difference of 7 and 7 again. Well, that's 0. And then finding the difference of 9 and 7. You have 9 minus 7, that's going to be 2, right? And then again, we'll have 9 minus 7. That's right, just taking our time with it. And we end up with these values for the differences, the positive differences of each of the values in our data set. And those deviations are 0, 4, 0, 2, and 2. You want to find out the mean, the average of these 5 values, all right? And that will give you your mean absolute deviation. Remember, the reason why we have absolute in the title is because we're finding the positive differences of each of these values, all right? So let's check it out. Here we go. So the numbers that we'll be finding the sum of are 0, 4, 0, 2, and 2. So adding these numbers, we'll have 0 plus 4, which is 4. 4 plus 0 is 4. 4 plus 2 is 6. And 6 plus 2 gives us 8. All right. So we want to then take this sum and divide by 5 in order to find our mean absolute deviation. So dividing by 5 here, you'll have 5 going into 8. Let's figure out how many times. We know that 5 goes into 8 8 once, and that's going to be 5. We'll then change the sign. 8 minus 5 is 3. And I'm going to go ahead and show my decimal here, as we will be rounding this result to the nearest tenths place, all right? So I'm going to add a 0 and bring that down so that 5 goes into 30 6 times, all right? So what we find here is that our mean absolute deviation for this problem is 1 6 tenths. 1 6 tenths. And here we go. I'm going to box this answer up again because that's what I love to do. So 1 6 tenths is the mean absolute deviation. That's it for problem number 2. All right. For problem number 3, we have the data set 98, 99, 52, 42, 14, 41, and 95. And we are asked to find the mean absolute deviation of these values. So the first thing is we need to add all these values together, all right? So let's do just that. Our first value is going to be 98. Then we have 99, 52, 42, 14, 41, and 95. And you want to find out the sum of these 1, 2, 3, 4, 5, 6, 7 values, all right? So that's what we want to do first. So adding this together here, I'll have 8 plus 9, which is 17. 17 plus 2 gives me 19. 19 plus 2 is 21. 21 plus 4 is 25. 25 plus 1 is 26. And then 26 plus 5 gives me 31. I'm going to go ahead and curry. I'm going to curry the 3, all right? I curried it right up there. Can you see it now? It's right there. There's that 3. Let's go ahead and add that now. We'll have 3 plus 9, which is 12. 12 plus 9 is 21. 21 plus 5 is 26. 26 plus 4 is 30. 30 plus 1 gives us 31. 31 plus 4 is 35. And then finally, 35 plus 9 gives us 44. So our result here, this sum, is 441. So what we want to do with this sum next is divide by the amount of values that we had in our data set, which is 7. So 7 will go into 441 how many times? Let's figure it out, right? So we have 7 going into 44. That goes in there 6 times, right? So 6 times 7 is 42. I'll change the sign. I'll bring down a 2 and bring down that 1. And 7 goes into 21. What's that? Yes, you're absolutely correct. 3 times. Very good. So this is our mean of this data set. That's the average. That's what we want to find first. So now that we have this, we need to find the change, the difference between each one of these values and the mean, all right? And the positive result is what we need in this. So let's go ahead and move to our next page to figure that out. So I'm going to be finding the difference of 98 and 63 first, all right? So that's going to be a 5 there. That's going to be a 3 there. That's 35. We also have 99 minus 63. This is going to be a 6 here. That'll be a 3 there. Then you end up with 63 minus 52. Remember, I need the positive difference between these values. So this is going to be 63 minus the 52 to ensure that I end up with a positive result, all right? So notice how I purposely put the larger number on top to ensure that I get a positive result when finding the differences here. Next up, I have 63 minus 42. This gives me 21 as a difference. And next I'll be looking at 63 minus 14 here. I'm going to go ahead and borrow here. All right, that gives me 13 minus 4, which is 9. 5 minus 1 gives me 4 as a difference here. All right, next I'm looking at 63 minus 41. That gives me a 2 here and a 2 here, so that change is 22. And then finally I have 95 minus 63. Subtracting these numbers, I have a 2 here and then a 3 here. So that gives me a result of 32. All right, these are all of our deviations. All right, so we have 35, 36, 11, 21, 49, 22, and 32. All right, so listing all of these, we're going to find the sum of 35, 36, 11, 21, 49, 22, and 32. All right, and we want to find the sum of these values. So adding these together, we have 5 plus 6, which is 11. 11 plus 1 is 12. 12 plus 1 is 13. 13 plus 9 is 22. 22 plus 2 is 24. And 24 plus 2 gives me 26. So I have my 6 here, and I'll be curring the 2. All right, curry the 2. We have the 2 plus 3, which is 5. 5 plus 3 gives us 8. 8 plus 1 is 9. 9 plus 2 is 11. 11 plus 4 is 15. 15 plus 2 gives me 17. And 17 plus 3 is 20. So our sum is 206. You then want to divide this 206 by the amount of values that we have, which is 7. So, setting this up in long division as we do, we have 206 divided by 7. So dividing this out, we have 7 goes into 20 twice. That gives us 14. I'll then change the sign. I'll then subtract and end up with a 6 here. I'll bring down that next number, which is a 6. And 7 goes into 66 9 times. 9 times 7 is 63. We'll subtract to get a 3, and then I'll need to add a decimal here. All right, and add another 0. I'm going to extend this. Bring down this 0 to find that 7 will go on to 30. That'll be 4 times. All right, 4 times 7 is 28. All right, I'm running out of room, so let's go ahead and bring that 30 over here and then subtract that 28 from it. So that'll give us 2, and then I'll add another 0. All right, and once you bring that 0 down, you'll end up with 20 here, and 7 goes into 20 twice. Right? So once again, we'll be rounding our result to the nearest tenths place. So we ended up with 29 and 42 hundredths, but rounded to the nearest tenths place, that first place behind the decimal, because our value here in the hundredths place is less than 5, we'll need to round down. So we'll end up with 29 and 4/10 as our mean absolute deviation. Let me go ahead and box that up. There you have it. That's the answer to problem number 3. And on to our next and final problem, we have problem number 4 coming up. For problem 4, we have this data set. We have 22, 14, 37, 87, 22, and 25. So the first thing is we need to find the mean of these values. And we have 1, 2, 3, 4, 5, 6 values this time in our last problem. All right, so what we'll be doing here is listing the problems so that we can add them. We have 22, 14, 37, 87, 22, and 25, and we're going to add these values together. So I end up with 2 plus 4, which is 6. 6 plus 7 is 13. 13 plus 7 is 20. 20 plus 2 is going to give me 22, and then 22 plus 5 is 27. I'm going to go ahead and bring down that 7. I'm going to curry the 2. All right, I just curried it right there. So adding these together, I have 2 plus 2, which is 4. 4 plus 1 is 5. 5 plus 3 is 8. 8 plus 8 is 16. 16 plus 2 gives me 18, and then finally 18 plus 2 is 20. So our sum here is 207. We need to divide that sum by 6 because that's the amount of values that we have here in our data set. Remember, it was 1, 2, 3, 4, 5, 6 values in the data set. So you have 6 going into 207, and then 6 goes into 20. What's that? 3 times, because 3 times 6 is 18. We'll then subtract after changing the sign. I bring down that 2, and I bring down the 7, and then 6 goes into 27 4 times. So 4 times 6 is 24. I'll then subtract, bring down a 3. I'm going to need to add a decimal here, okay? We'll be rounding to the nearest tenths place in this problem. I'll be adding a 0 and bringing it down so that this is now a 30, and 6 goes into 30 5 times. All right, so there you have it. You have 5 times 6, which is 30. That terminates now. So you'll end up, let me put this in full view for you. So you'll end up with an average, a mean of 34 and 5/10. So this is the value that we'll be using to find the difference between each one of these values here, okay? All right, so let's find our deviations on the next page. So subtracting 22 from 34 and 5/10, we'll have this scenario right here, all right? And you'll end up with a difference of 12 and 5/10 for that first difference, that first deviation. And now subtracting our mean value of 34 and 5/10 from 14, we have 34 and 5/10 minus 14. This gives us 5 here, 0, and then a 2, so that difference is 20 and 5/10. Next, we'll be finding the difference of 37 and 34 and 5/10. All right, so remember to line up those decimals. I'll need to borrow from the 7. It becomes a 6. The 0 becomes a 10, and 10 minus 5 gives us 5. 6 minus 4 gives us 2, so that difference or deviation is 2 and 5/10. Yeah. Next up, we're looking at the difference between 87 and 34 and 5/10. Notice how I'm always putting the larger value on top to ensure that I end up with a positive result. Line up those decimals. You'll end up borrowing from the 7, it becomes a 6. The 0 becomes a 10. 10 minus 5 is 5. 6 minus 4 is 2, and 8 minus 3 gives us 5 for a result of 52 and 5/10. Yeah. Next up, we need to find the difference of 34 and 5/10 and 22. Line up your decimals. 5 minus 0 is 5. 4 minus 2 is 2. And 3 minus 2 is 1 for a difference of 12 and 5/10. And finally, our last difference to find is going to be between 25 and 34 and 5/10. So let's set that up. All right. Lining up your decimals, you have 5 minus 0 is 5. 4 minus 5 won't happen. You'll need to borrow. So borrowing from the 3, it becomes a 2. The 4 becomes a 14, and 14 minus 5 is 9. So your result here is 9 and 5/10. So highlighting all of our differences, all these deviations, we have 12 and 5/10. We have 20 and 5/10. We have 2 and 5/10. You have 52 and 5/10, 12 and 5/10, as well as 9 and 5/10. These 6 values you need to now find the average of. Okay, so let's set that up. So we're adding together 12 and 5/10, 20 and 5/10, 2 and 5/10, as well as 52 and 5/10, 12 and 5/10, as well as 9 and 5/10. There they all are, right there. Okay, let's go ahead and line up those decimals now and go ahead and add this, shall we? I know that 5 plus 5 is 10. 10 plus 5 is 15. 15 plus 5 is 20. 20 plus 5 is 25. 25 plus 5 is 30. I'll bring down a 0. I'm currying a 3. That's a 3 up there. Yep, I know it looks like a growth. It's a 3. 3 plus 2 is 5. 5 plus 0 is 5. 5 plus 2 is 7. 7 plus 2 is 9. 9 plus 2 is 11. 11 plus 9 is 20. 0. Curr the 2. 2 plus 1 gives me 3. 3 plus 2 is 5. 5 plus 5 is 10. 10 plus 1 is 11. We end up with 110 as our result, ladies and gentlemen. That's right. It's this sum that now needs to be divided by what number? How many values did we have? 6, exactly. We have 6 going into 110. All right, let's check it out. 6 won't go into 1, but it will go into 11 once. 1 times 6 is 6. Change the sign, bring down the 5, bring down the 0. 6 goes into 50 how many times? Very good. 8 times. 8 times 6 is 48. You'll then subtract. Bring down a 2. We're going to add a decimal and a 0. Bring it down. 6 goes into 20 how many times? How many times? It's going to be 3 times. 3 times 6 is 18. Absolutely. Then you'll be subtracting from there and you'll bring over a 2. Add another 0. 6 goes into 20 how many times? That's right. 3 times again. See, that 3 is going to keep repeating here. But don't fret, because we're rounding to the nearest tenths place, and as long as this value is less than 5, then we just need to round down. So rounding 18 and 33 hundredths to the nearest tenths place gives us a result, we're going to write it over here, of 18 and 3/10. This is our answer, ladies and gentlemen. That's the MAD. That's the mean absolute deviation for problem number 4. Yeah, that's the mean absolute deviation. You just found out how to get mad, ladies and gentlemen. So anytime somebody says you're angry, nah, just tell them you're mad. There you go. Mean absolute deviation, ladies and gentlemen. This is Mr. Witt with Fort Bend Tutoring. As always, please rate, comment, and please subscribe. It makes a difference. And if you're able, please donate, as that helps us bring you more free math tutorials from me, Mr. Witt, and Fort Bend Tutoring. Peace.
Thanks for watching. We feel great knowing that you got some help and you're safe and sound. Now, if you'd be so kind as to like this video, subscribe to our YouTube channel, Fort Bend Tutoring, and like us on Facebook, we'd be much obliged.